Thanks for the introduction, Jan. As you heard, my name is Stefan Jensen from Scantech. Now, this is an interesting project I'm going to speak to you about in Malaysia. It's a high-rise, what we call a high-rise in the trade jargon. So it's 32-meter ceiling height, 3 freezers with 32-meter ceiling height, and an automated ASRS, automatic storage and retrieval system. And then there's a couple of anterooms, shallow anterooms in front of that. So these are the items I'll be going through with you, how the project came about, what was driving it towards low charge ammonia. We'll be discussing the layout, how the heat loads were estimated both by the consultant and myself, all the problems we encountered, all the building delays, what COVID did to us, and then I'll show you a few things about the end result and the energy performance that was recorded. So it all started at the Atmosphere Conference in Singapore on the 4th of September in 2018. That was back in the day when we could still fly around the place. So I was in Singapore presenting at the Atmosphere Conference, and in the audience there was a gentleman from Malaysia who became quite interested in this particular graph. And I'll just explain what this means. So for those who were here the previous session, what we have here on the vertical axis is what we call specific energy consumption in kilowatt hours per cubic meter per year. And along the horizontal axis, we have the cold store storage volume or refrigerated volume in cubic meters. And this formula here comes from a report that was prepared in California in 2008. This was when Mr. Schwarzenegger was the governor. And this was funded by Californian taxpayers, this project. And it recorded the energy performance details of about 160 something public and private cold stores. I think that most of them were private, about 100, and public cold store, that was about 60 something. And this curve here is what was drawn up on the basis of the feedback from that investigation. So this is called, sorry, let's go back again. This is called average practice, the top one, and the bottom one is called best practice. And the gentleman in the audience, he saw all these yellow crosses here, which are the energy performance records of a selection of low charge ammonia plants in Australia. One is in China, this one here, Dongguan, and the other ones are in Australia. And what he became interested in was the clear difference between what these plants achieve and what the average achieved in California in 2008 was. Up here we have an ammonia system with single stage economized screw compressors, and you can see the energy performance of that plant is almost off the chart. So 4 or 5 things that were really important to the Malaysian client. First of all, the demonstrated low specific energy consumption. Secondly, there's a lot of evidence that the system that this particular client already owned was consuming about 4 times too much energy compared with what it could have achieved. And of course, the owner wanted to address that problem. The third thing was the high-rise. In a high-rise situation, if the system is done with liquid overfeed, the wet return line coming from high level, if the evaporators are mounted at high level, will fall something like, if the engine room is on the ground anyway, something like 25 to 30 meters. And that can cause pipe work vibrations, and it can cause pipe stresses. It's much better to have a dry suction line coming down to the plant room at ground level from the evaporators at high level. And the safety issue associated with large ammonia charges in a liquid overfeed system are well known, and this particular client wanted to address that. In other words, he wanted to get the charge down. The facility is an inner city facility, so it's in a very built up area with businesses and residences and other things all around it. So here we see the plan view. So where my cursor is now, that's 3 freezers. The rooms are called H, I, and J. And 2 are freezer rooms, and the third one is a chiller room. The third chiller room can also operate as a freezer. And here we see ante rooms in 2 levels. And here we see the plant room. Dimension of one freezer is about 80 by 14 by 32 meters. So the total refrigerated volume is approximately 112 to 113,000 cubic meters. So it's quite a large, medium-sized facility, I would say, not as large as the ones we discussed this morning. Here's an enlargement of the engine room area. Here, the compressors. This is not the way the plant was designed. This is an early version. So we see here vertical vessels. That's not how they are in practice. And we have only 4 compressors with allowance for a 5th one, right? So here is the bottom ante room. And you can see I made a little enlargement here, or section. So that 4-fan evaporator is this one. And there's another ante room on top of that, which is fitted with a 2-fan evaporator. So up here on the first floor, we have the plant room. So it's necessary to climb a flight of stairs to get up to the plant room level. So it's not the suction line from the top of the freezer and down to the plant room level drops approximately 25 meters. This is the evaporator here. So the evaporator draws air back from the freezer where my cursor is. It does a U-turn and it comes back here. So I've enlarged the evaporator arrangement here. Air comes in here, turns around, goes through the evaporator and out into the freezer. So there's some couple of pictures here of the high-rise during construction. So this is the impression from the ground. You can see these guys here on the cherry picker. Is quite a long distance down to the ground. Now, there was a consulting engineer involved by the name Jean-Marie, based in Singapore. Both Jean-Marie and myself had a go at calculating the heat loads. And of course, the heat loads were very much a function of how much heat rejection you allow from the materials handling system. Now, this is an automatic materials handling system, and it is very much a wild guess what the usage factor is of that materials handling system. So in most of these high-rise jobs, everybody has a tendency to be conservative. And quite often that means that the refrigeration plant finishes up being significantly oversized. You can see here, when we use the materials handling heat rejection that the consulting engineer wanted to use, we get these figures, 150 to 170 kilowatts in the freezer rooms and a little bit less in the chiller room. And that adds up to about 600 kilowatts total, with an even spread between low temperature and high temperature. The minimum loads, this is at night time when everything is quietened down, no materials handling system is operational. not a lot of traffic in and out, and not a lot of product heat load. And you can see here that then the heat load is significantly less. So this emphasizes the importance of having a plant that will deliver good part load performance. And there are a great many plants out there in the real world that do not do that. So this is the predicted energy performance. We have some homemade software that predicts the annual energy consumption for a facility such as this. And we came to a specific energy consumption predicted of 10.5 kilowatt hours per cubic meter per year. The client, of course, wanted some sort of guarantee, and which is fair enough, of course. If he's going to pay top dollar for an energy efficient system, or a system that purports to be energy efficient, you would want to have some guarantees that it's also going to deliver. So the guarantee we provided was 15 kilowatt hours per cubic meter per year. And if that is exceeded, there would be a discount. In other words, the client would be able to discount the total price of the project by an agreed percentage that was nailed down in the contract. We've ended up recording a specific energy consumption of 8.5 kilowatt hours per cubic meter per year. This is not quite over a full year yet, but it is over a sufficiently long period to be representative. It may even get better. We don't know this yet, but we might know in a year's time. Now, just as a comparison, the existing system that is there is a screw compressor plant, two-stage plant with liquid overfeed, and it services the existing facility, which is approximately 35 to 40,000 cubic meters in refrigerated volume. So it's significantly smaller than the new facility. And the specific energy consumption there is 60 kilowatt hours per cubic meter per year. So approximately 5 times bigger than the predicted, and approximately 6 times bigger than the actual recorded specific energy consumption. I believe that plant has now been turned off and everything has been moved into the new facility. And the older facility is used for higher temperature storage. So this is a little bit about the refrigeration plant design, the new one. You see 4 reciprocating compressors, 12-cylinder reciprocators. And here we see the low and high temperature vessels. You will note there are no pumps. This is the purger. This is the priority vessel. And this is the evaporative condenser. Full stainless steel 316. Stainless steel, I know I've said 304, but it's actually a 316 stainless steel condenser. High pressure float valve. You see high pressure float valve here. And the ammonia charge is around 500 kilograms. We don't know exactly because we actually had to commission this plant by remote control because of COVID. Now, this was not by any measure an easy project. Design started around October 18 with some preliminary discussions with the client. And the client came to Australia in January 2019 to visit 5 systems in Sydney and Brisbane and Melbourne, I think. Maybe not, maybe we didn't go to Melbourne. Anyway, that's not important. The project started in March 2019, and the pull down was very ambitiously set for October 2019. Then we sent our first people over there, and COVID hit. And commissioning was late 2021, so late last year. An exceedingly difficult job. I finished up having to contact a good friend in Malaysia, whom I met in Switzerland in 2018, and ask that person nicely if he could help us finish the plant off, because it was impossible to travel at the time. and this gentleman agreed to help us, and that's how the plant was completed, and that's how it was finally handed over. So very difficult. So here the picture on the left here of the finished plant room. You see the two horizontal vessels in the background and the four compressors here in front of the vessels. This is the lower of the two ante-rooms. You see the 4-fan evaporator here. And this is the evaporator arrangement in room J. So this is where the air returns down the bottom from the freezer compartment, makes a 180-degree turn and goes back out through the evaporator. So this is a dry expansion ammonia evaporator with electronic expansion valve in the usual fashion. And this is the 316 stainless steel condenser, fully imported from Germany. And here you see the condenser fans. These are the compressor VFDs. So this is the booster VFDs, and these are the 3 second stage machine. There's actually only 2 second stage machines, but one is fitted with a large motor, so it can run dual duty, low temperature or high temperature stage. You know, the detail here, these are the purge reservoirs. So this is where the air that gets into the plant is collected and taken to the purger. That's all I had for you. So I welcome any questions you might have. Thank you.
Thank you very much, Stefan, for your presentation. So I would like to take this opportunity to welcome questions from any of the attending participants. Again, Stefan, we had this discussion in the morning about the energy consumption, about the annual savings, about the return on investment, right? So you have promised to deliver 15 kilowatt-hour per cubic meter efficiency, and you have got to 8.5, right? That says something about the happiness of the customer. Can you comment on these results? Was it surprising to you as well to get so low?
No, not really. I knew that the heat load was overestimated, and secondly, the client decided to. He's only running on 2 compressors at the moment out of the 4 compressors, and one reason for that is that he's only running 1 room as a freezer. The 2 other rooms are running as chiller. So of course that reduces the energy consumption somewhat, but you see there, we gave ourselves some buffer. I'm very confident that we could have achieved 10.5 even with 2 rooms running as a freezer. But you know, I wasn't going to guarantee that because there are just too many unknowns. So because the client wanted a guarantee, I left myself 4.5 kilowatt hours per cubic meter per year buffer.
There was a peculiar problem, I remember, a year and a half ago, when you were saying something that is delaying the commissioning further, and there was something about the monkeys and the virus. Do I remember well?
Yeah. Yeah, because of all the delays, right? I mean, nature starts to move in on the plant, and the monkeys, they chewed on the insulation of the cable, so we had to replace a lot of cable. So I mean, this was just one of the many problems. We had many other issues. We had delivery delays, and we had problems. The plant owner had serious problems with the building, with the construction company that was responsible for constructing the facility. We were delayed repeatedly by, and I mean, communication was a really big problem. We could not leave Australia for the best part of 2 years. So everything had to be done by remote control. Everything had to happen by telephone and Zoom and all sorts of other things.
This experience of basically commissioning such large projects remotely, did it help you to be prepared for next such project? Are you more confident that, or is it something you just want to avoid, that you better be on the ground, of course, with your team?
The electrical part was actually not so bad. What happened was the electrical commissioning per se happened from Australia between our electrical engineer and an electrical subcontractor in Malaysia. So it was a simple case of putting the PLC program and the SCADA system software in via the internet. And the sort of the hardware commissioning, of course, we couldn't do that remotely. That had to happen via an electrical subcontractor in Malaysia. We did end up hiring a PLC expert from Singapore to go up to Malaysia and help us with the on-site commissioning of the PLC. Of course, there were things that that person didn't know, and all that had to be explained on the phone or on Zoom, and of course, this slows things down a lot. But there's a lot you can do with a simple iPhone and then holding the video camera on whatever topic you want to discuss, and then communicate on the basis of the picture that is being recorded on site that then goes back to Australia.
Number of companies we discussed this morning with Panasonic, Hussmann, and they have also been commissioning. They have actually developed number of tools to help to enable this, remote commissioning for other projects. So this led to this, let's say, innovation in the industry, right? From the necessity is the mother of all invention, as they say. I'm wondering.
We were going to buy a $5,000 pair of glasses. They're like these glasses you put on, and then whatever the wearer of the glasses sees, you can see on your screen. But we took the view that these glasses will come down a lot in price. Mm-hmm. And therefore we didn't make the investment at the time, and I'm sure they'll come down to $500 in the not too distant future.
There is a lot of talk about the augmented reality and this remote viewing and using tools remotely, all of it, right? So I'm sure you're right that this thing is coming. You mentioned in the morning that you are now very busy of rolling out of these scam packs, right? When you have basically container filled with the ammonia compressors as a pre-manufactured package that you deliver to the site. Next project somewhere in Southeast Asia. We don't know when it happens, but would you say that this will be the design that you would come up with, the technical solution?
Unfortunately or fortunately, depending on your point of view, COVID has brought about a lot of this development, because we also had severe travel restrictions in Australia. When COVID was really going gangbusters, it wasn't even possible to leave Queensland, and we couldn't have visitors in Queensland because the borders were shut. But it was possible to ship equipment, right? So shipping a containerized plant room to a site in WA or Sydney or Melbourne or somewhere is much easier than sending a whole truckload full of bits and pieces and then get someone locally to put it all together for you. So I see the scan pack as a possible export item, or a piece of equipment that you can export. Now, a scan pack will, in a 40-foot container, will run a freezer store that's approximately 20,000 cubic meters, a mixed cold store, so with chillers and freezers and anteroom. And most of these little scan packs all over Australia, they run small facilities, like typically food service facilities of that size. And just 10 years ago, this was not something that anyone would even consider running on ammonia. It would have been all air-cooled 404A with electric defrost, but that is changing.
My last question to you, Stefan, are you eyeing some project outside of Australia these days, or is just too busy with the domestic market?
We're simply too busy in the domestic market. That's just the reality of things.
Understood.
And I don't think we're the only ones. I think everyone's busy.
Okay, as long as it's busy with natural refrigerants, all fine. Stefan, thank you very much today. Your second presentation was equally interesting, and we will continue this session with our next speaker from Malaysia, actually, which is going to be about cold storage with CO2 transcritical. So that will be interesting comparison. Mark, welcome to Atmosphere Asia Pacific and to our session focusing on Southeast Asia. Can you hear me, please? If you can unmute and join us with your camera, that would be great.
Hi, Jan. I can hear you well. Good afternoon to you.
Excellent. Good to have you here. How are you today?
I'm fine. Can you see me?
Now I see you. Great. It's actually the first time for us to be able to communicate. So happy to have you here joining today.
Welcome and thank you. Happy to see you as well.
Excellent.
Can I start now?
Yes, you can please share your screen, your presentation, and we are all ready and looking forward to your slides. If you can go full screen and then ready to go. Thank you very much.
Konnichiwa. Good afternoon, ladies and gentlemen. I would like to humbly introduce myself. My name is Mark, who is from FFM Engineering, a one-stop HVACR company located in Malaysia. We offer design, supply, build, maintain, and service of HVACR systems, particularly in Malaysia. And I'm going to present to you a topic, namely performance of the first CO2 contribut installation system in cold storage sector in Malaysia. These are the contents of the presentation that I'm going to run through in the next 15 minutes. Sorry, yeah. How do I make it full screen? I'm trying to get a bar that is blocking me from seeing the full screen.
I think you can press escape to get out of the full screen. Yes.
I did it, but
What do you need?
I'm talking about the Zoom bar that's blocking the top session, which I can't see the title of the top session of the presentation.
The title of the top session, I'm not sure I understand. What is the
let me try, hold on.
If you want to move slides, no.
Let me try.
We can see the complete slide there.
Yeah, I can't see the complete slide. I mean, it looks like the top session is being blocked by the Zoom bar that shows about the stop video, the participants, the chat, Q&A.
Okay. We don't have this problem here as a viewers, so it's difficult to help.
It's okay.
Thank you.
As you can see, I think this is the market of the CO2 transcritical installations in Southeast Asia area, and the data was recorded in May 2020. As you can see, Europe has the highest installation rates. We're talking about 26,000 installations as of 2021 May. It is followed by the States and Canada with about 500,000 installations. Then we have Japan with 5,000 installations. The installation for Southeast Asia region, which is hot and humid, have recorded a double digit, as you can see here, 13 and 14, with a foreseeable growth. These are some of the climate data in Kuala Lumpur, Malaysia. The Kuala Lumpur is the capital of Malaysia. The ambient temperature is averagely about 28 to 29 degrees. There are few dry months and few rainy months in Malaysia. As you can see here, the rainy season is basically, I think, driven by the monsoon rain when it comes. And the RH is recorded to be about 80.4 averagely. And we recorded about 200 rainy days a year usually. And this is the industrial CO2 refrigeration unit that we sourced from Nihon Extrusion, Japan. That we can talk about it later. CO2 refrigeration systems were rare in Malaysia, 5 to 10 years back. And we only saw cascade system here back then due to the technical incompetence, the high cost, and of course the low acceptance of CO2 in Malaysia. And we started to have the interest in this transmitter system back in 2019, where when we visited Japan, JESCO presented us a few of their installations in Japan. But we were particularly impressed by their installation in Kauai ice storage in Fukuoka. It was about the robustness, the efficiency of the unit that initiated our first project in Malaysia. We heard many of good reviews from the staff in the Kauai during our visit in 2019. After that, we made several trips to Nihon, and their engineer actually came to Malaysia as well to discuss about the Pioneer project in Malaysia. And that's how we started our cooperation with Nihon. The unit was delivered during the COVID pandemic in 2021. We were anxious because JESCO was supposed to come to do a TNC and start the system. Well, we made so many virtual calls before the successful TNC finally, and the rest are history now. And we have a happy client. And this is the F2 unit with about 80 kilowatt nominal kilowatt at its design parameters, 35 degree ambient and evac temperature of minus 82 degrees C. This is the location of the cold storage. This Tongseng Food is where we launched our first Pioneer project in Malaysia. They are one of the biggest frozen dim sum or Chinese food suppliers in the region. They have about 50 to 60% market share of dim sum supplies in the region. The cold store is about 5,000 meter cube in volume, cooled by one F2 80 kilowatt condensing unit from Japan. The unit started to operate, I think, since early 2021. And these are the pictures of the inside and outside of the building. This is the annual operation data recorded real-time via PLC. You may see from the water nozzle that cools down the gas cooler ambient, the data recorded for the whole year. It kicks in at 35 degrees C and stops at 32 degrees C. The RT is kept at minus 20, the inside room temperature, throughout the year. And we're talking about the ambient of 25 in the morning could be, and 35 usually in the afternoon when it is hottest. And the operation is seamless, consistent, stable. It doesn't even cough, as you can see from the graph here. This slide shows the energy saving of CO2 compared to R22 system by simulation. As you can see from here, I think we do have about 15% saving when you compare the R22 simulation with the actual data CO2 unit consumption in Malaysia for the past whole year. Conclusion, we landed the pure CO2 transcritical refrigerant system in Malaysia for cold storage in 2021. It is stable, it saves money, and we have a very happy client now. And I think for months to come, we'll be installing another 2 units in Malaysia. There'll be one in July, a bigger unit, F3, about 120 kilowatt. And subsequently, there'll be another one in November as well, F2. The inquiries are getting more and more, and we hope Malaysia will become greener with more and more of these CO2 installations. Thank you very much.
Hello, Mark. Thank you again for your presentation. I would like to take this opportunity to invite the questions from our participants. I have also been informed that we have the technical team from Nihon Netsugen Systems also available to help answer some of the more technical questions if we receive any. Before that, I would like to, please go ahead, Mark, if you'd like to add anything. Okay, so question for you, Mark. This couple years ago, we have talked about the first CO2 transcritical installation in Malaysia, and that was for a small convenience store. Did you have a chance to visit this? Was there some, did you have any other previous experience with CO2 before working on this project?
Yes. Ian, were you talking about the test port?
No, I'm talking about Panasonic condensing units were installed in the small convenience store. I think, was it not?
Yeah, basically, Yeah, I think it's by OK, I think about 7-8 years ago by Panasonic. No, basically you see that is a small system when compared to the one we installed recently. Basically, I think that was a small one. And I think they got a pioneer project for that particular system in Malaysia via government. And after that, I think there were not much development until recently. Where we started to go into this sector again with more, of course, I see advertisements and effort to get the government to support more in terms of rebate subsidy.
Yeah, no, I do remember that this project was supported by the government in Malaysia, as you said, right? We talked about this project in Bangkok at our conference when it was the year it was installed. I'm wondering, the industry, is there more interest into CO2 transcritical? This is still this is the first project in industrial refrigeration, right? Is it the beginning of more kind of wilder interest among the industry in Malaysia? Do you have?
I can see it basically. I think the biggest challenge is still about the cost to install the CO2 system in Malaysia. With government, I think spending more effort to subsidize. Of course, you see rebate and yeah, I mean the tax exemption. I think the interest will be growing more. But of course, you see we are working closely now with the factory in Japan to bring down the cost. One thing, and second thing, of course, to get government to understand and to basically, I think basically to accept this product as green product, and so as they can, get more subsidy such as solar energy and EV product in Malaysia. Things are growing. So basically, I think in work in progress. We are foreseeable. We are foreseeing a better prospect for this particular thing in Malaysia soon.
That's good to hear. And you are now pioneering this solution in cold storage. Are you open to share? Do you invite the representative from government or the other cold storage operators, the contractors, to learn about these new technologies? In the beginning, we always experience a lot of fear of unknown, and there is now a great example of this technology to be running well in the ground.
Again, we are more than willing, basically, I think, to share knowledge. With that particular experience we experienced, I think, in the past, it's not a problem at all.
Okay, so
at the end of the day, I think we hope the Malaysia can accept this product. I think in the mass basically acceptance.
We have heard a lot in past 10 years about CO2 having difficulty in high ambient temperatures, but that has been the thing of past. The efficiency has been proven in this installation in Malaysia. Are you happy with the system, how it performs when it comes to energy efficiency?
Exactly, I think that's what you mentioned. Basically, we fear about the high pressure, the high ambient thing. I think, but you see with that particular, site visit in Hawaii Food, Japan. So we interviewed the people over there. We were basically, happy to see that how Nihon, they started a product that basically convinced the people to use. And we decided to bring in the product and to test the market in Malaysia. After the trial, it was successful and people are happy about it. In fact, you see, there are so many people visiting the site on a monthly basis. So we are glad to see the acceptance of the people slowly. Just that we need to make sure that the government can pump in more subsidy and acceptance exemption so as people feel okay about the cost.
Okay. In Japan, you visited Japan, you saw the CO2 system at the location. In Japan, the market is driven by subsidy from the Ministry of Environment. Do you see an opportunity in Malaysia to also start similar program or something to support the end users?
There are more things to be done here in Malaysia. We need to do more things, I think, to convince them.
Okay. What can help convince them? What is it the thing that the industry needs to do?
I think you see more visits to them to tell them about the concept, about how Europe and how Japan they have progressed thus far. I think we need to make more effort to convince them.
You are happy with this first project? Do you have plans to install more of these systems?
Basically, I think very happy. We just ordered 2 units. They are coming to Malaysia in a month time. We've had 2 more projects with the similar units in Malaysia. Okay. There are 2 more projects upcoming within the year.
Excellent. So you are extending this CO2 systems in your facilities. Yeah. What do you see to be the challenge when it comes to training of the industry, or do you see training to be one part that maybe there's some hesitancy from the other players?
Training basically, training should be conducted more, I think, either locally or even going back to our principal Japan, and we are doing that now.
And regarding the commissioning, I understand that this was commissioned fully remotely as well because of the COVID and impossibility to travel. Can you tell us a little bit more about that experience, please?
You see, we were nervous initially. You see, Japanese, I think, talking about Jesco, they promised to come here, that they start everything, they will do all the T&C, we will just learn from them. But due to the COVID and due to the end user requirement to start unit, so yeah, we were panicked. But anyhow, I think they're committed by video conferencing. We're doing it basically on a daily basis, even hourly. Basically, I think with this current advancement of technology, video call, I think difficulty is slowly overcome.
All right. Well, good to
I don't
hear.
see a big problem now.
Okay. So remote commissioning, and we have heard from other panelists today as well that this is the reality, and they have developed new tools to make it, to make it even easier, including all the remote monitoring and reporting. So we will see hopefully more of these technologies to be deployed in Southeast Asia. We talked about an additional project in Malaysia just in this session, and there is much more happening. So we hope to hear from the stakeholders in other parts of Southeast Asia, Thailand, Indonesia, Vietnam, about the natural refrigerants and the latest project. So great to see that you are now committing to more of these units to be installed, and happy to hear when you are ready to share about how these units perform and having more data, a couple of years of data to report on. We'll be happy to work with you again. Okay, thank you very much, Mark. Have a good day.
Bye-bye. Have a nice day. Have a nice day.
Bye-bye. All right, so now we are going to jump into the update about the Cold Chain Innovation Hub that will be presented by yours truly. So I will go ahead. And first of all, I will just refer to the homepage of the project. So I don't know if you are familiar with the project. Many of you might be. This is a 3+ year project that is funded by Global Environmental Facility and implemented by UNIDO. The official name of the project is the Global Partnership for Improving the Food Cold Chain in Philippines. And it has a number of components: policy and regulatory assessment, awareness and capacity building on use of energy efficient technologies, and the technology transfer, establishing the partnership between the leading industries outside of Philippines and the domestic industry. So project partners, as I mentioned, Jeff, UNIDO, local partners, DNR, the Ministry of Environment in Philippines, TESDA, training institute in Philippines that is hosting the actual hub. And SHECO, nowadays Atmosphere, is one of the executive partners. So I have prepared a few slides to give you an update about where we are with the project and what the opportunity is for the industry to get in touch. Happy to receive any questions about what this opportunity might entitle. So I have actually just returned from Manila 10 days ago. It was great to be there working with the industry after more than 2 years since we could not travel. How many times I said it today? Probably 10 times. But yes, we are now able to travel again, and it's great to reconnect with the local industry. So a few notes about the progress of the project. So I would like to start with thank you to the current contributors at the hub. So these companies have contributed with their technology, with their know-how, with their expertise, with their tools, materials, anything that can be part of creating this center of excellence for natural refrigerants in Philippines for the food cold chain application. So thank you very much for the 24 already on board. We are welcoming others, of course. We are in discussion with several other companies. And again, we hope that everyone will participate in helping the local industry to get access to the best technology and the latest expertise. So thank you to the existing contributors. These contributions are ranging across all sectors of food cold chain, and examples from transport refrigeration. Carrier Transicold contributed with the 10 feet 20 feet natural line CO2 container. We are working with a couple of companies on the refrigerated truck using R290 module. So that's a pilot project that will be assembled locally. The unit is supplied by Product Blocks European manufacturer. I'm very happy to also present the CO2 training rack. This is not the latest version of that, but the CO2 rack will be provided by Japanese supplier Nihon Netsugen Systems, and we are very excited about having the systems shipped and commissioned at the hub and to be fully operational this summer, so that the industry can have access to the latest technology for training on CO2. Another example from the commercial refrigeration, we have showcases, plug-in systems, water loop configuration, units from companies like HT, Guntner, Grundfos, EPTA, Embraco, Nidec, of course, Panasonic, Hussmann, supplying their CO2 technology, both showcases and condensing units. So more the merrier. We're very happy to equip this technology in the hub and hoping to have access to more. So if you have technology that you would like to enable access to at the hub for the local industry to be permanently exhibited there, used for training, even temporary exhibits are a possibility. Any systems that can be used for training are very much welcomed. And this is the right time to get in touch. This is just an example of a couple of the pieces, equipment reaching the hub. So this is the Embraco plug-in cool unit, temporarily just shown right after it was received. We are, this is a off-grid post-harvest refrigeration system by Westfrost in Denmark. And we have just, I'll get to this installation in particular. So we are also welcoming the contribution on the side of the training and knowledge and expertise, expert time. So a number of companies are offering their both contracting services as well as know-how. So even if you are unable to travel, you can still connect via Zoom to give a lecture on the handling of refrigerants or you know, starting up of the CO2 transcritical system, handling of tools and so on. There's an opportunity for everyone who is willing to be part of this. We have finalized, of course, a lot of arrangements when it comes to shipping of the technology. That process is quite complex. I'll just move on. Then a little bit about the hub itself. So the Cold Chain Innovation Hub is one of the important aspects of the whole project. And it's located at the premises of the TESDA campus near the Manila airport, very easy access, and in close proximity to all the important institutions. Again, TESDA is hosting this hub, and it's a very important leading partner of this project. The training of the trainers, the experts at TESDA will be equipped to train the local industry, going through the program, you know, working with the global leaders to acquire the necessary knowledge and expertise to be then able to train the local industry themselves. So this is just a few pictures from the process of the renovation that is now fully completed. And I'm happy to show you to some of you, maybe for the first time, that this is the brand new facility, fully renovated. It's a 500 meters squared of space that is used for this permanent exhibition and installation of the natural refrigerants systems for food coaching. So in this room, we will have the CO2 training rate with a walk-in cooler. We will have showcases. There will be the container with CO2 transcritical system. All these technologies are either being shipped or being underway already somewhere at the sea. So we have a lot of space to work with, still plenty of space to fit your equipment. Is it CO2, ammonia, hydrocarbons, water or air? Everything is welcomed. Even the, of course, tools to handle these technologies or materials to install these systems is very much welcomed. So this is still work in progress on these pictures, but we are using R290 split type air conditioning that was installed at the training room. So even the air conditioning is provided by natural refrigerants, and we have just organized a training or industry gathering there 2 weeks ago, and it was working very, very well, keeping everyone cool. So this is one of the last touches. The whole building is also being painted from outside, and you can see the outdoor units again of the R290 air conditioning. We have initiated a number of first pilot projects. One of them is the R290 refrigerated track. Another one is it's a solar-powered off-grid refrigerated cabinet. And I'm happy to show you that this has been completed. This installation is now available at the hub. So we are starting the monitoring and energy performance evaluation of this unit. You see the solar panels on the right side that were installed just outside of the coach innovation hub in close proximity to the R290 outdoor units. You see the power setup, the inverter, battery system. So this is now fully off-grid solution that provides minus 25 degrees refrigeration. And the idea is that in Philippines, there is many off-grid locations that would benefit from refrigerated space to eliminate food loss or to reduce food loss, to preserve their harvest. So we are looking into the option to deploy this technology and many other technologies that will be exhibited at the hub to the industry to really help to make one of the first steps for the new technologies to be available on the ground. So this project has been just completed by the Tesla experts last week, and we are happy to see more and more technology be reaching the ground. We have also worked on a number of assessment reports that are available on our website. This is one of them, focusing on the evaluation of the commercial refrigeration system installed at the Royal Duty Free shops using R290 in water loop configuration. So this report is available online on the website I have previewed earlier. So the demonstration projects are the next important component for us in terms of the priorities for the year: securing more contributions, carrying out the demonstration projects. So we would like to help bring this technology to the market, as I mentioned. CO2 condensing units, R290, water loop, off-grid solutions based on R290 or 600 isobutane 600A, or a CO2 transcritical. The more the merrier. Again, we are looking for the suitable recipients. So we are working with the domestic industry. That was one of the reasons I have also visited Manila recently. And again, we are looking forward to make significant progress this year on the project, working very closely with the industry. So this is still the part of the report that I have prepared, that I have mentioned before. Plans and activities. So right now we are in the final stage of arranging the shipment of a number of these contributions. This is not going without difficulties, right? The current supply chain globally is being severely disrupted. So this has been delayed, but the technology is reaching us, and we are very thankful for that. We would like to have as much as possible of these systems that were contributed, if not all, to be available and commissioned, installed this summer in July by mid-August. And in September, we would have an invitation to the contributors, and the industry would like to preview all these technologies to the local industry. We would like to start, we plan to start a regular training program, again, leveraging the technologies that are installed, available for the training. Securing additional contributions is always on our mind, so please reach out to me if you want to be part of this with your technology, with your expertise, with your tools. Carrying out the demonstration projects, as mentioned recently, and again, we intend to monitor and analyze the efficiency of these systems that are deployed in the market, so that the industry have access to the information, to the right data, and to make a decision about the future deployment of these technologies. So this is in short the update from the project. These are the pictures from just 10 days ago, a week ago, actually. It feels like a month ago now, but it was great to be there at the hub, seeing the actual facility, working with the local industry. We organized an informal industry gathering, so maybe some of the listeners are on the picture as well. And again, it was great to be there, working with the local industry and hopefully inspiring some of the new contributors, some of the new suppliers that are not yet fully on board to be part of this. This is an opportunity for us to work together to help push, to advance this market towards latest, most energy efficient, sustainable technologies. So it's something that we believe is very exciting. We are humbled and honored to be part of this, and we hope that you will also recognize this opportunity and get in touch with us. So with that, I would like to say thank you for your listening.